So this is a video about how to do titration calculations. The question says, in a titration, a 25 centimetre cube sample of HNO3, which is nitric acid, reacted exactly with 20 centimetres cubed of 0.40 moles per decimetre cubed sodium hydroxide. The question wants us to find the concentration of nitric acid. This has to be done in several steps. The first step is to write a balanced equation. So, HNO3 aqueous reacts with sodium hydroxide, also aqueous, to produce sodium nitrate and water. Now, for this reaction, the thing that we need to note here is that we have a ratio for every 1 nitric acid, we have 1 sodium hydroxide. The ratio has to be between the hydrogen ions, the H+, and the hydroxide ions, the OH-, because we're making 1 molecule of water. Be careful if you have a question with sulfuric acid, because sulfuric acid has 2 hydrogens. So, we've written our balanced equation, which is our first step. The next thing then is to pick the information out and put it in the relevant place. I would recommend making 2 columns, one for your acid and one for your sodium hydroxide. The information given to us in the question is that we have 20 centimetres cubed of sodium hydroxide and it has a concentration of 0.40 moles per decimetres cubed. The nitric acid, we're told we have 25 centimetres cubed. By picking the information from the question and putting it into 2 separate columns, it should help you to organise your answer. So if step 1 was writing the equation, step 2 is finding the number of moles of sodium hydroxide. The sodium hydroxide is aqueous, which tells us it's a solution. We're given one value which is a volume and one which is a concentration. So straight away you should be thinking moles equals concentration times volume. I use the shorthand N equals CV. Vacuum cleaners are noisy. However you need to remember it, learn this equation. The only trick to this bit is that we need to change our volume from centimetres cubed to decimetres cubed. So putting that into our equation, N equals concentration, which is 0.40, multiplied by our volume, which is 20. We need to divide it by 1,000 to make it in decimetres cubed. This gives us the number of moles, 8 times 10 to the minus 3. So we now know that the number of moles of sodium hydroxide equals 8 times 10 to the minus 3 moles. That's the end of our step 2. Step 3 is really important. Step 3 is that ratio. How many moles of nitric acid do we have for every moles of sodium hydroxide? From our equation earlier on, and I've kept it in my columns, we have a ratio of 1 to 1. Which means that if I had 8 times 10 to the minus 3 moles of sodium hydroxide, I would also have 8 times 10 to the minus 3 moles of nitric acid. I've now got some extra information about my nitric acid. I want to find the concentration. I know the number of moles and I know my volume. So I can go back to my N equals CV. But I need to rearrange that equation to get the concentration on their own. So if volume is a multiple on this side, I make it a fraction on this side. N over V equals C. I can now do my final stage, part 4 of my calculation. So step 4, using now C equals N over V. I'm going to get rid of this information as we don't need it anymore. So the concentration equals the number of moles, which is 8 times 10 to the minus 3, divided by the volume. We've got the same problem here that our volume is in decimetres cubed. Instead of making a complicated number, fraction and a fraction, I can turn the bottom fraction upside down, do 8 times 10 to the minus 3 divided by 25 times by 1,000. That gives me a final value in the correct units of 0.32 moles per decimeters cubed.